We can use Genie in the context of globalmantics by collecting and parsing VRF data using its pre-made parsers. Let's begin by changing into the Genie directory. Our goal is to update our VRF getter playbook to store JSON data instead of plain text. Let's first install the collection we discussed in the slides using the command shown. We can confirm it was installed using the handy tree command. Now, we see 3 collections with Clay's Genie collection at the bottom. Here's a quick screenshot of Ansible Galaxy if you want to learn more about this collection. It wouldn't be a good use of time to explore those details right now. All the auxiliary files are the same as they've always been, with one new group variable added. The VRF command variable helps reduce copy-paste errors by specifying the command to run on the devices. Remember, we must also supply this to Genie so it knows which parser to select. Let's explore the getvrfgenie.yaml playbook next. First, we'll send the specified command, which was show vrf detail. This doesn't collect the running config, but the command does reveal all the route targets, so for our purposes, it works fine. Then, we'll invoke Genie. I'm using the YAML folded text operator to split a single line across multiple lines for readability. You don't need explicit quotes here, as they are implied. Let's extract the CLI text from the VRF output variable and pass it into the parser, referenced by fqcn. We also need to specify the command, and this is why having a generic variable is handy. Last, specify that these are iOS XE devices, which is technically different than iOS. If you want a full list of Genie parsers per platform, check out this documentation link. Here's a screenshot from the documentation, which shows how I confirmed that Genie has an iOS XE parser for show vrf detail. You'll definitely want to start there before writing any code. Let's quickly check tasks 3 and 4. Creating an outputs directory hasn't changed at all, so we won't review it. Saving the parsed data to disk requires a few updates. This isn't plain text, so let's convert the data to human-readable JSON with 2 spaces of indentation. Also, change the file extension from .txt to .json as a best practice. Let's put Genie to the test by running the playbook. The playbook succeeded, but let's scroll up so we can see everything. The first 2 tasks run without issue and don't report any changes. For a data collection playbook, this is expected. The outputs directory didn't already exist, so Ansible creates it. Then, Ansible creates a JSON file for each host in the inventory. Let's quickly explore the r1.json file. This is a dictionary where the topmost keys are the VRF names, making it easy to access the data. These parsers are very advanced and collect tons of information, including address families and obscure hexadecimal flags. We won't scrub the whole file, but notice the route targets key contains a nested dictionary. Unlike a list, you'd need to iterate over this using withDict or the new loop construct with the dict2items filter. Here are a few conceptual examples to show how that might work. In Python, you'd typically unpack this structure using the dict.items function combined with a for loop, which is what Ansible does behind the scenes. Feel free to explore the r2.json file on your own, but it works similarly. I've included examples of both in the dataref directory for your reference. If you want to challenge yourself, try to work this data structure into the really good CLI-based IAC solution we developed earlier in the course. You can bypass all the custom parsers, but much of the Ansible and Jinja 2 logic has to change. This is a great way to practice implementing a difficult refactor.